This parameter, cluster_optics_xi, in scikit-learn's optics clustering algorithm sets the threshold for reachability distance. It's like a tuning knob that determines how close data points need to be considered part of the same cluster. A higher value means a stricter threshold, while a lower value allows for more distant points to be grouped together. This is the central question of the quiz. We're exploring how adjusting the cluster_optics_xi parameter impacts the final results of optics clustering, which is a density-based algorithm. The question helps to explore how parameter tuning affects the results. This statement explores the effect of increasing the reachability distance threshold. A higher cluster_optics_xi makes the algorithm more sensitive, resulting in many smaller, tightly grouped clusters. Imagine drawing smaller circles around tightly packed points. The opposite scenario, a lower cluster_optics_xi, sets a less stringent threshold, allowing more loosely connected data points to be included in the same cluster. This leads to fewer, but larger clusters. Picture drawing fewer, bigger circles to encompass more widely spread points. This statement points out that the best value for cluster_optics_xi isn't universal. It greatly depends on the specific structure and characteristics of your data. It needs to be determined empirically through experimentation and comparison of different values against the specific dataset. This statement is false. The minimum number of data points for forming a cluster is not directly controlled by cluster_optics_xi. While optics uses ideas from DBSCAN, it does not share parameters for minimum cluster size. Other factors, like data density, influence this. This refers to the core concept behind cluster_optics_xi. It's the cutoff distance in the optics algorithm. Data points with reachability distances below this threshold are grouped into the same cluster. It's the crucial distance that defines what constitutes a cluster. This refers to the distance used by the optics algorithm to determine whether points should be grouped into the same cluster. Think of it as a ruler measuring how close data points are to each other. Points within a certain distance from each other would be deemed part of the same neighborhood. It's a critical parameter that dictates the outcome. This refers to the distance used by the optics algorithm to determine whether points should be grouped into the same cluster. Think of it as a ruler measuring how close data points are to each other. Points within a certain distance from each other would be deemed part of the same neighborhood. It's a critical parameter that dictates the outcome. This refers to the distance used by the optics algorithm to determine whether points should be grouped into the same cluster. Think of it as a ruler measuring how close data points are to each other. Points within a certain distance from each other would be deemed part of the same neighborhood. It's a critical parameter that dictates the outcome. The reachability distance threshold directly impacts how the optics algorithm forms clusters. It decides if points are considered reachable from each other and thus grouped. A crucial component in forming final clusters. The reachability distance threshold directly impacts how the optics algorithm forms clusters. It decides if points are considered reachable from each other and thus grouped. A crucial component in forming final clusters. The reachability distance threshold directly impacts how the optics algorithm forms clusters. It decides if points are considered reachable from each other and thus grouped. A crucial component in forming final clusters. When the _cluster_optics_xi value, represented as xi, here, as high, it sets a stricter threshold for reachability. Only points extremely close to each other will be considered as part of a single cluster. This leads to many small clusters being identified. Think of it like having a tiny sieve, only the tiniest particles will go through. When the _cluster_optics_xi value, represented as xi, here, as high, it sets a stricter threshold for reachability. Only points extremely close to each other will be considered as part of a single cluster. This leads to many small clusters being identified. Think of it like having a tiny sieve, only the tiniest particles will go through. When the _cluster_optics_xi value, represented as xi, here, as high, it sets a stricter threshold for reachability. Only points extremely close to each other will be considered as part of a single cluster. This leads to many small clusters being identified. Think of it like having a tiny sieve, only the tiniest particles will go through. This is the core question of our quiz. We need to determine which statements about the clusteropticsxi parameter in optics clustering are correct. This parameter is super important because it sets a threshold on how far apart points can be to be grouped together. Let's analyze each statement carefully. Think of it like this. A higher clusteropticsxi value acts like a stricter filter. Only points really close together will be grouped into clusters, leading to lots of smaller, tighter groups. This statement is true. Conversely, a low clusteropticsxi is like a wider net. Points further apart will be considered part of the same cluster, leading to fewer, but larger clusters. This is also true. The best value for clusteropticsxi really depends on the data itself. Dense data might need a higher value, while sparse data might need a lower one. It's all about finding the setting that makes sense for your particular dataset. You'll need to experiment to find what works best. So yes, this is true. This one is a bit of a trick. Clusteropticsxi sets the distance threshold, not the minimum number of points. The minimum number of points in a cluster depends on other factors and the algorithm's logic. Therefore, this statement is false. Hey Vamsi, this question is all about understanding how the *cluster_optics_xi parameter affects the results of optics clustering. It's a key parameter that controls how sensitive the algorithm is to finding clusters. We need to carefully consider each statement's relation to this parameter. Let's look at statement C. This statement suggests *cluster_optics_xi directly sets the minimum number of points needed for a cluster. That's not quite right. *cluster_optics_xi is more about the reachability distance between points, not directly about the number of points in a cluster. The minimum number of points is usually influenced by other parameters in the optics algorithm, which is based on DBSCAN principles, where the min_samples parameter plays a more direct role. It's important to remember that optics uses density-based clustering, considering point densities and reachability to group things together. Statement D is true. The best value for *cluster_optics_xi really depends on the specific dataset. What works well for one dataset might not work for another. Imagine trying to find clusters in a dataset with densely packed points versus one with widely scattered points. You'd need a different level of sensitivity, and thus a different *cluster_optics_xi for each case. It needs experimentation to find the right value. Think of it like tuning a radio. You need to adjust the dial, *cluster_optics_xi to get the clearest signal, best clusters, for each station, dataset. Now for statement B, a smaller *cluster_optics_xi value means the algorithm uses a more relaxed threshold for cluster formation. It's more likely to group points together, even if they're a bit farther apart in reachability distance. This will lead to fewer, but larger, clusters. It's like having a wider net. You'll catch fewer fish, clusters, but each catch, cluster, will be larger. Statement A says that a larger *cluster_optics_xi will result in more, smaller clusters. That's correct. With a higher *cluster_optics_xi the algorithm becomes more strict about what it considers a cluster. Only points very close in reachability distance will be grouped. This is like using a very fine mesh net. You'll catch lots of little fish, small clusters, but maybe miss some bigger ones. This section introduces the concept of optics clustering and highlights the importance of the parameter. It sets the stage for understanding how this parameter influences the clustering results. Think of it as laying the groundwork for the quiz questions. Let's dive into understanding the core concept. This is the quiz question, provided about the parameter based on its definition and behavior in the optics algorithm. Are you ready to tackle this quiz? This statement explores the impact of a higher value. A higher value makes the algorithm stricter. It's like setting a higher bar for two data points to be considered part of the same cluster. This stricter threshold leads to more, smaller clusters. Does that make sense? This statement explores the opposite scenario. What happens when you decrease the value? It makes the algorithm more lenient, so points are more readily grouped together. It's like lowering the bar. This leads to fewer, but larger clusters. Can you visualize this? Here, we are examining whether directly dictates the minimum number of data points needed for a cluster. Optics doesn't directly use minimum cluster size as dbSCAN. So the answer to this one is no, not directly. Let's think about it. What other factors might determine the minimum cluster size? This statement discusses the optimal value of. The optimal value heavily depends on the specific characteristics of the dataset. It's like finding the right recipe. You'll need to experiment with different ingredient levels to achieve the best outcome. Do you agree? Statement A is correct. A higher value results in more, smaller clusters due to a stricter threshold for cluster formation. Statement B is also correct. A lower value results in fewer, larger clusters due to a more lenient threshold. Statement C is incorrect. Does not directly control the minimum number of samples in a cluster. Other factors influence that aspect of clustering. Statement D is correct. The optimal value depends greatly on the dataset, requiring adjustments and experimentation to find the best clustering outcome.